Hey everyone, welcome back to Pine Hollow out of Diagnostics. Look at this thing. 2015 Kawasaki side-by-side 850 3-cylinder towed all the way from West Virginia, like 4 hours away, because no one down there could figure out why this thing is going to this reduced speed mode. What is reduced speed mode? Well, basically the owner said in high range he can only go about 10 miles an hour and in low range about 4 miles an hour. So it has great throttle response, it starts right up, it runs great, but as soon as it reaches that speed it just starts either cutting fuel, kind of limiting your speed. So it seems like an intentional speed limit problem. They have, it went to the dealer, it went to other shops. No one could pinpoint why it's going into this mode. I mean, it could be anything from, hey, you left your parking brake on, to you didn't plug in your seat belt, it's not setting any warning lights or notifications or messages. When I got here, this little sensor was unplugged for the seat belt, and that does work. So if you turn the key on, the little seat belt guy is there, and if you plug in the seat belt into here, that goes out. So I don't think that's the issue, but yeah, let's take it for a spin and see what it does. By the way, let's take a quick peek under the hood or the bed. So it looks like a 3-cylinder fuel injected unit. I saw that made in China coils. I don't know if those are OEM or not. Obviously we'll check the engine oil. Owner said he changed it pretty recently. We are right near the full mark, so that's good. Yeah, let's take it for a rip and reproduce the customer complaint. Alright, so turn the key on, and we just have the seatbelt guy. So the parking brake, the light does not come on, and it's reminding you to buckle up, so we'll buckle up. There we go. Okay, seatbelt guy is out. We're neutral. Press the brake. So it fires right up. So in high range, right there, 14 miles an hour. Slow down. So I'm going to just punch it to the floor. So this thing is like a 4-wheel burnout. Let's look at the speedometer. So as soon as it reaches 14, it'll start cutting out. Let's do low range. About 8 miles an hour. Okay. Now what if we just rev it up? It's not a rev limiter. Put it in reverse. It goes 14 in reverse as well. So customer complaint confirmed. Now we figure out why is it doing this. Alright, let's figure out why this side-by-side doesn't want to go fast. Why is the speed being limited? So plan of attack is we need a good OEM wiring diagram and see what the inputs are to this engine computer that could possibly be enabling this speed limiter. First I want to start by turning on the key and making sure that this display, that all the warning lights work and function properly. So for example, neutral, reverse, that works just fine. The parking brake light, the bulb check works, but even if we release the parking brake or engage it, that is MIA. So we'll note that. The seat belt sensor seems to be operational. If we plug in the seat belt, goes out right away. We also have temp, oil pressure, CVT, check engine light, electronic power steering. So all the bulbs work, the display, the miles per hour are, that's accurate. The four-wheel drive, two-wheel drive, four-wheel drive, that works fine. So that's what we have to work with. Let's go find a wiring diagram. So the owner was kind enough to provide a link to the OEM service manual, which is very handy, and they do have an electrical schematic listed. So I printed that off. It's 2 pages. It kind of looks like a motorcycle wiring diagram. So it takes a little bit of time to trace it out, follow it out. I spent about an hour on it and took notes and did some wire tracing. So let me show you what I'm focusing on here. So first of all, here is the ECU. So this is the engine computer. It also controls the four-wheel drive actuators and the diff lock actuators. So what are the inputs to this engine computer? So things like speed sensor. We know the speed sensor works. It reads the miles per hour just fine. And things like the seat belt use reminder switch. Where does that go? So for each wire, going to each one of these sensors that I'm interested in, I basically traced them back. For example, this one is just the ground. It goes to this ground point. See the blue? And then this orange wire goes right here. So I just marked up the basically the wires 1 through 28, so I can easily move on to the next page. And that goes right to our combination meter. Okay, so in combination meter, it looks like it has 8 wires going to it, 1 through 8, and I traced each one, and basically here's what they are. Pin 1 goes to the seat belt, pin 2 goes to the fuel sender, pin 3 goes to the electronic power steering. That's for that EPS light. It's pretty neat. We have electronic power steering on a side-by-side. Pin 4 goes to the ECU. There's a wire that goes from here to here. So we don't know exactly what that does yet. Let's keep going. Pin 5, battery positive. Pin 6, ignition power. Pin 7 goes to our oil pressure switch, which is right here. That looks like it's just grounded, so that's a simple warning light. And then pin 8 is ground. So then my question is, well, how does this meter display the gears, display the four-wheel drive position, and the speed? So that all comes on pin 4. It must be a single wire communication. It's not a network, it's just like a LIN. It goes from here to the ECU. So on that wire, these two modules, the ECU and the meter, can talk. Now, that opens up, a lot of possibilities of why the ECU is limiting the speed. Because, for example, if the meter says, hey, our seatbelt's unbuckled, it could send that information to the ECU, and this will limit the speed. So that's why we need to look at the inputs to here and here. They're both important. And if you go on forums, people will say common issues with these that limit the speed is seatbelt switch, parking brake switch, stuff along those lines, kind of safety items. So we'll definitely start with those and go from there. By the way, let's take a quick look at the description of the problem from the customer. So it's a little lengthy here. Not sure if you were willing to work on a side-by-side. This is definitely a difficult diagnostics case, which might make a good YouTube video. Stuck in a limp mode with no check engine codes. I had it to the local dealership as well as to another sports shop. Neither were able to diagnose the issue. Does not have an OBD connector. Uses self-diagnostic code system. Nearly every sensor has its own code, but I've not gotten any codes. I bought this side-by-side used, for, like a commercial company. It has 8,000 miles on it. Started, ran fine. Couple tanks of gas. Was doing great, and then it started acting up. So I hit a few bumps, maybe went through a couple shallow mud puddles, and then anytime I apply throttle, it doesn't want to go above 10 or 14 miles an hour. Cuts power and surges. They typically act if the seatbelt is unplugged or if the emergency brake is pulled. Between myself and Rami Cycles, we did the following to try to correct this issue. Here we go. There we saw on the forums. I have issues with the parking brake and seatbelt sensors cutting off the engine. Seatbelt sensors were all unhooked when I got the buggy, but I hooked them all up and unplugged the parking sensor. Still no luck. In fact, it made the engine cut out at half the speed as previous, which leads me to think that whatever the issue is, it must be something similar. Replace the spark plugs, wires, coil windings, etc. Fuel filter, fuel pump. Blew out the fuel lines, cleaned the fuel injectors, confirmed the cooling fan is functional, drained the tank. So all this stuff right up to here. The engine has great throttle response and revs up nicely, and then it's an intentional fuel cut. Why would you bother doing all those things? I mean, I guess if you have no other ideas, then for sure. But you could just say that's definitely not going to work because it couldn't possibly be the problem. So coolant hose, they replaced the CVT belt, okay, wear and tear stuff. Romney Cycles tested some other circuits, finally unplugged the speed sensor, took it for what must have been a short ride and went over that speed. So they declared victory and gave it back to me. Unloaded it from my trailer and got home. Didn't get a quarter mile from the house when it threw a speed sensor code from the unplugged sensor. And I assume it went back to that limp mode. Would have been happy to live without the speedometer. Tried removing speed sensor and connector plugged in while plugging the hole. That works for a very short time. Then it throws a speed sensor code. Cleaned the terminals. Charged the battery. Recommended to replace the computer wiring harness. Bought a used computer off eBay, swapped it in. That didn't fix it, so I swapped the old computer back in, returned the eBay unit. Wow, there is one spot in the main wiring harness underneath that recently discovered outer cable sheathing is missing. Cleaned up the wires underneath, inspect them, don't see any broken wires. The guy at Motorsports didn't actually do more than just a few circuit tests. He called a lot of other friends he had in dealership shops. No one has seen this issue before. He didn't want to replace the wiring harness without knowing it was the issue, to waste time and money. Well, okay, good. At least they didn't replace the harness, because that's probably not the issue. I brought it home with the intention of removing the wire harness, thoroughly inspect and possibly replace it. I'm having a hard time working myself up to that amount of work. Required to remove all the plastic, unplug the connectors, blah, 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 creating other issues. Yes, that's smart. So at this point, he's like threw in the towel and towed it over here. That's where we are. So a lot of stuff has been done to this side-by-side, and no one's been able to make heads or tails out of it. Alright, well, we're just going to go by the wiring diagram. No troubleshooting trees, no, anything else, just this. And by looking at a wiring diagram, 9 times out of 10, you can figure out how a system works and what the logic is. It takes time, but you will have a very specific game plan once you're done taking notes here, and we won't miss anything. So basically, on the ECU, what are the inputs that could cause this speed limit? So again, I went through all the sensors and see if they connect to the ECU or the meter. So here we go. The parking brake switch, single wire, goes right to the ECU. So that must be a pull down circuit, And then the ECU transmits that information on the LIN wire, the communication wire, to our cluster to light up that parking brake little bulb. So the bulb doesn't work. Does that mean, it works on a bulb check, but when the parking brake's engaged, that bulb does not light up. Now, does that mean the computer thinks that the parking brake is always off, so it wouldn't even be an issue? Perhaps, but it doesn't work as designed. So I do want to check that, but I don't think that's going to be causing our issue. Brake lights. Interesting. So the brake light switch sends power, right here I highlight it in yellow, to the brake light bulbs, there's two of them, and also to the ECU. So I'm sure the ECU wants to know if you're pressing the brake and the gas at the same time, it'll just, cut the fuel or whatever. So that's a monitored circuit. I want to check the brake lights. I haven't checked them yet. I want to make sure the brake lights work as intended. The seatbelt buckle, that works fine. The little light comes on when it's unbuckled and goes away when it's buckled. So, that circuit is good, and if that information is being sent to the ECU, it should be appropriate. So I'm not worried about seatbelt. And then another variable here is the differential lock system. If you're in four-wheel drive and you press the diff lock, I'm sure some systems don't want you to go too fast with the diff lock on it, because you wouldn't need to. How is that system controlled? Well, there is a diff lock switch right here. 3 wires. It actually lights up when you flip it on, and you can see right here, so off, the 3 pins are disconnected, on, all 3 pins are connected. So again, if this is a ground wire and this is a power wire, that must light up the little LED in the switch. And then this third wire, it looks like a P, I think it's a pink wire, that gets grounded, and that is the request right here, diff lock switch. So that must be pulled down by the switch, and the computer should know when you press the button. And then the ECU sends voltage here to this diff lock actuator relay. Then that closes and sends power to this diff lock control unit. And then the little motor here, diff lock actuator, moves the diff lock in place. And when you flip the switch off, then the ECU says cut the power to this relay, it unlatches, and then the diff lock control unit moves the motor the other way to the limit. That position is not monitored. It's only an output of the ECU. It doesn't have, a little switch on the differential saying, hey, we're engaged or disengaged. Nope, it's just, hopefully the ECU assumes that it works. The four-wheel drive system does have switches for 2 high, 4 high, and 4 low, I guess, and that seems to work because this display shows if you're in low range or 2-wheel drive, 4-wheel drive, and low range. So these are the things I want to check. We can jack the rear of the buggy up, make sure the diff lock works. The customer did say he was having some issues with it. But then we'll focus on the parking brake and the brake lights. Alright, so I'll turn the key to start. I'm wondering if in 2-wheel drive you can lock the differential. Let's see. Something definitely clicks. And in 4-wheel drive, it clicks. So this is your only indicator right here. And I guess in low, there's no little light. It's supposed to be obvious that you're in low range. Okay, very neat. Let's okay, see that ignition cut out after a few seconds. Let's jack up the rear of the buggy and see if that diff lock button actually works. Alright, so I got the rear axle jacked up. If we spin this wheel this way, the other one goes the other way. So right now the differential is definitely open. Now, turn the key on. So differential locked. And let's see. Nope, didn't do anything. Differential is still open. So here's a little diff lock motor. We can see if this is clicking or what's going on. That definitely didn't do anything whatsoever. Alright, so I unplugged this plunger solenoid, and I just want to see if that clicking sound goes away. So now we just hear a relay up front and nothing going on in the back. So electrically everything works, but whatever's inside this differential definitely does not work, because it makes no difference if that plunger is in or out. Okay, so I think we can rule out diff lock because it's a commanded circuit, but it's not a monitored circuit. So next, let's try the parking brake. So the little P should light up when you pull the parking brake. I took out the cup holder, and right here is just that single wire switch. And what we could do is maybe pull it down with a test light and see if the little light comes on. Maybe the switch is just bad. Alright, test light, got it connected to that metal bolt. Just an experiment. I don't know if the test light's properly connected, as in if it has a good ground, but touch that. Oh look, little P comes on and goes off. So we know the actual little switch here must be busted because it doesn't ground that wire. However, that would not prevent the speed limit, because this thing just thinks your parking brake is always off, which is, you know, normal operation. So we can say the switch is bad, but it would definitely not cause a problem with the speed limiter. If it got stuck on, always grounded, then yes, that would be an issue. We could just unplug it. But in this case, that's not going to be our issue at all. Well, we're doing pretty quick work here. Last thing on the list monitored by the ECM is brake lights. Let's see if those work. Alright, so I got the key on. Let's see what's going on back here. So we got a light here, and this light doesn't it look brighter? Definitely looks brighter. Actually got the bulb out. Right, just a regular 1156 or 57 dual filament bulb. You can see on this one, I don't know if the camera's going to pick this up because it's so bright, but the brake filament is on instead of the tail. And right now, only the tail lights are supposed to be on. So that is incorrect. Okay, on this one, you can see the little filament is on, so that's tail. So if we push the brake pedal, let me depress it with my snow brush, and there's just like a motorcycle type sensor right here. It's just a little pull spring. Let me get that down and see if the brake lights come on. Alright, so the switch is definitely pulled out. It's extended. I don't see, nothing changed. So the brake lights are not working, and this filament is wired up wrong, I think, because this is the OEM connector, and then here looks like it got ripped off. Then you got electrical tape, so they probably spliced the wrong wires. The tail and the brake, they probably reversed them. Maybe, but this is suspicious. But I'm sure it didn't happen while the guy was riding along. But we need to figure out why the brake lights don't work at all. Okay, so we're going after this brake light switch. So we have power coming in on, I traced it orange, it's a brown wire, and when you press the switch it should send power out on the blue wire. So test light, I pierced both wires. The red probe is on the brown wire, the black probe is on the blue wire. So first let's check for power with the key on. We have good power feed to the switch. Okay, let me rig up a different test light and then we'll mess with the switch. Alright, so we definitely have a good power feed here. I'm on 4 amps grounded. Now, let's go to the other wire. So if I press the brake pedal and the switch is good, it should send power to the brake lights and at least to my 4 amp test light right here. So I'm pressing the brake pedal, there we go. So you got to pull it quite a bit to enable the brake pedal. We could turn the switch out, use this little adjuster nut, so you got to pull it that far. Let me adjust that, we'll depress the brake pedal and see if that fixes our brake lights. Okay, so I got the switch adjusted, so it engages right about there where the pedal starts getting hard. I think that's pretty good. So if we stuff our snow brush into here, have the switch on, okay, did the brake lights come on? Nope, they sure did not. Well, that's interesting. So somewhere between the switch and the brake lights, there is an open circuit in this yellow tree. So we're good to this connector, I know that. But it's also not making it to the ECU. And maybe if the ECU never sees a brake input, it says, hey, we have no idea, you know, even when you start it, if you're not on the brake or something, it'll say, let's just do safety mode because we have no idea what's going on with the brakes. So this is promising. Let's see if we can find this wire that goes to the ECU and to the brake lights. So our ECU is conveniently mounted under the hood right here. Got it unplugged. I love seeing gobs of dielectric grease in connectors. That's always it's not the end of the world, but too much dielectric grease just gets everything messy. I want to pop off this connector and find the pin that goes to the brake light switch and see if the brake light input is making it to our brain. Alright, let's straighten out this taillight situation. So I got both taillights unplugged. Well, actually you can't unplug this one. I just unwrapped the splice job here, and sure enough, the tail wire is going to the brake filament. The ground is, you know, good, and this one the solder came off, but the brake wire is going to the tail filament. So that was reversed. That's confirmed. Let's plug in a test light pair. This is the OEM connector. So from ground to the tail wire, that should come on when I turn the key on, and it does. Now let's move that actual pin from the tail to the brake in here like that, and let's try pressing the brake and see if the brake lights come on. Make sure I depress it appropriately here. Okay, so the brake light circuit works on this side. Now, why didn't it work before? Let's plug in the regular bulb. Actually, I'll tell you why. Because this wire came right out when I unplugged it, so that explains why we had no brake light here. But why did we have no brake light or tail filament lighting up over there? I don't know, but let me clean up these wires and make sure the tail and the brake lights work. All right, here we go. So that's taillights. These 3 wires are soldered up. I had to replace the bulb. The taillight filament was burnt out anyways, and that's why we didn't have any brake lights on that side. I fixed the broken wire on the other side. Okay, now we should have bright brake lights on both sides. Hooray! But did that solve the customer complaint? I don't know. Let's take it for a spin. Alright, let's see if we made any difference. Parking brake definitely works. Alright, place your bets now. How fast is this thing gonna go? Unbelievable! It's fixed! Actually surprised. I thought it might not work. But what was the root cause? Misadjusted brake light switch. And then the brake lights didn't work because of a broken wire and a badly wired bulb. But the bulbs didn't have anything to do with it. The computer needs to see a brake switch input to say, hey, the brakes are good, we can go full speed. So that's amazing. The customer will be like, we did this. How much would you charge for this? The whole diagnostics and repair? I'd probably say about 3 hours with a discount. About an hour and a half of research, drawing up the wiring diagram. Hour for all the wiring repairs back there. Brake light switch adjustment. I mean, yeah, I think that's fair. It's fixed. Top speed, about 40 miles per hour. So, pretty cool. Wiring diagrams, all you need, and some logic. You can figure stuff out. Alright, we'll see you in the next one. Bye-bye.